Welcome. Today we're going to talk about special products. We're going to continue working with multiplying polynomials. So the first special product we're going to look at is called the square of a sum. So we've got a sum in here in our parentheses and we're squaring it. So that means we have x plus 4 times itself. So common misconception here is that you're going to get x squared plus 16, just a binomial answer. Well, if we look at it in our area model, we've got x plus 4 by x plus 4. So in this box, we have an x by x, which is x squared. Here we have 4 by x. Here we have 4 by x again, and then in our last box we have the 4 by 4, which is 16. So these two can be combined because they're like terms. So we're actually going to get a trinomial product, x squared plus 8x plus 16. All right. This one I set up to do by foiling. So 2x plus 3, so we've got a sum that is squared, so square of a sum again. And if we multiply it out, our first product is 4x squared. Our outer product is a positive 6x. Our inner is a positive 6x again. And our last is a positive 9. These two can be combined, so we get 4x squared plus 12x plus 9. So again, we're getting that trinomial. The last one I made was a simple x plus y squared. So we've got x plus y, x plus y. So we're going to get our x squared. We're going to get an xy here. Remember, with two variables, you want to write them in alphabetical order. We're going to get another xy here. So we've got one of those and one of those. And down here we'll get a y by y, which is y squared. So again, we're going to get that trinomial. X squared plus 2xy plus y squared. Okay, next pattern. So our second pattern is called the square of a difference. So we've got a difference in here in our parentheses instead of a sum this time. So if we look at this in our area model, we would have an x minus 10 and an x minus 10. So we get our x squared. We're going to get a negative 10x and another negative 10x. And then down here we've got positive 100 because we've got a negative times a negative. So we're going to get another trinomial. X squared minus 20x plus 100. All right, here's one foiled. 49 y squared is our first. Outer minus 7y. Inner minus 7y again. Last plus 1. These two combine. 49y squared minus 14y plus 1. Trinomial. This example, we've got an x minus y, x minus y. So we're going to get x squared minus 1xy minus 1xy plus y squared. So if we combine these like terms here, x squared minus 2xy plus y squared. This is our third pattern. So now we are not squaring something. We have two different factors, but they're related, okay? Because the only difference in them is there's a subtraction in one and an addition in the other. So if we lay this one out in our area approach, we've got x minus 7 times x plus 7. So we're going to get our x squared. Here we're going to get minus 7x. And down here we're going to get a positive 7x. In this final box we've got a negative times a positive. So we're going to get minus or negative 49. So now when we look to simplify, these two will actually cancel out. So we'll have a binomial product. So x squared minus 49. So that's where the name comes from, is the product, that the answer is a difference of two squares. The first two were named based on what you were multiplying, not what you got as your answer. So here, we can FOIL this. So we've got y squared minus 8y plus 8y, I drew that arc in the wrong place, plus 8y, and then minus 64. These two cancel. Y squared minus 64. Last example of this type, we've got 3x plus 5, 3x minus 5. So we're going to get a 9x squared, 15x negative 15x minus 25. These two cancel. We're left with this binomial, which is a difference of two squares. Both of those are perfect squares. So to summarize, the three patterns that we were looking at are square of a sum, and there's your product, square of a difference, and there's the product. You notice the only difference in your products here are the fact that you have plus 2x versus minus 2x, and then difference of squares. And again, that name is referring to the answer being a difference of two squares. Okay, so that's all I wanted to cover in this one. Thanks for watching, and I'll see you next time.